All right, the Pascal's triangle is recommended to expand this binomial expansion, all right, to carry out this binomial expansion. So, from the lessons we had in the previous contacts, we had that our x plus y, everything raised to power 0 is 1. And then x plus y, everything raised to power 1, we have this leading coefficients, right? If you expand what I explained last time, you have x here, you have y here. That's the expansion of this. Because it's just raised to power 1, so it's going to be plus, but that plus is not showing. We are interested in the leading coefficient, so the superintending coefficient. So the next one is x plus y raised to power 2. For instance, you're going to have 1x squared, then you have y raised to power 0 plus 2x raised to power 1, then you have y raised to power 1 plus 2, all right, 2, you're going to have the next one, you're going to have 1, then x raised to power 0, y raised to power 2, right? So in computing this, you take note of the positions of the leading coefficients, and that was why we just simply wrote it will be 1, it will be 2, it will be 1. So if I'm going to do the one for 3, our x raised to power y raised to power 3 is going to give us something like this. 1 is going to lead the coefficient of the first term, and then we're going to have it like that. So that's going to be x raised to power 3, and then we have raised to y raised to power 0. The next one, this coefficient plus this one is going to be 3x squared. You have y raised to power 1. The next one will be this coefficient plus this coefficient. That's going to be 3x raised to power 1, y raised to power 2. Then finally, the leading coefficient is 1. All right. That's going to be x raised to power 0, then y raised to power 3. So this is the coefficient that will take the lead of that. So in the next one, if you continue like that, when you get to 4, it's going to be 1, then this plus this, that's going to give us 4, and then this plus this will give us 6, this plus this is going to give us 4, and then we have 1. So if we continue like that for the next one, for 5, we have 1, then add this to this, that's going to give us 5, we add this to this, that's going to give us 10, then we have 10, then we have 5, we have this. So carry out the expansion using Pascal's triangle. The leading coefficient for the expression raised to power 5 will have 1, 5, 10, 10, 5, and this. So if you have this leading coefficient, all you need to do is to be substituted for the first and second variables, and then the first variable here, the first term here, the powers of this x will be decreasing, and then the powers of this y will be increasing. Look at the order with which it is done. So we now say hence, if we want to do for this, our 3x plus 2y, everything raised to power 5, what it's going to give us is the first leading coefficient is 1, then we have 3x raised to power 5. That's referring to this. Okay, of course, this is the next thing. So it will be 2y raised to power 0. Then the next one is going to be, the leading coefficient is 5. So we're going to put that, then we have 3x raised to power 4. The power was 5 here, so it has reduced to 4 here. And then we have 2y raised to power 1. The next one, the leading coefficient is 10, so we will continue this way. That's going to be 10. Then we have 3x raised to power 3. We have 2y raised to power 2. The next one is 10 again. So we have 10, then we have 3x raised to power 2 into 2y raised to power 3. So the next one is 5. The leading coefficient is 5, so we have 2 now, sorry, that's going to be 1. We have 1 into 2y raised to power 4. Finally, we have 1, that's the last leading coefficient, and then we have 3x raised to power 0. We have 2y raised to power 5. This is what you will have, and then we go ahead and do our final computation. So from what we have down there, if we do that, we're going to have 3 raised to power 5, x raised to power 5. Of course, 2y, everything raised to power 0 is 1. So the next one is going to be, we have 5 times what we have here. That's going to be 3 raised to power 4, x raised to power 4, then y raised to power 1. Then the next one is we have 10. We have 10 multiplying by 3 raised to power 3, x raised to power 3. Then it is multiplying 4, or you can say 2 raised to power 2 y squared plus. So the next one is going to be 10, which is this. Then you have 3 raised to power 2 x squared. Then you have 2 raised to power 3 y cubed. Then the next one is going to be 5 times, you have 3x times 2 raised to power 4 y raised to power 4, and the final term is going to be, of course, 3x raised to power 0. That's going to be, so that's going to be 1. So you have 1 times, you have 2 raised to power 5 y raised to power 5 as the last term. So carefully compute this. 3 times 3 times 3 times 3 in 5 places, that's going to be 283. All right, no, that's going to be 243. And then you have x raised to power 5. The next one is, this is going to be 81. Right, sorry, there should be 2 here. This is 2y. So this, if you multiply this, that's going to be 81. 81 times 2 times 5. 81 times 10. That's going to be 810. You have x raised to power 4, y raised to power 1. So if you multiply this, is 27. 27 times 10. That's going to be 270. So if you multiply 270 by 4, if you multiply 270 by 4, that's going to be 0, this time this, that's going to be 28, carry 2 this time this, and then that's 1. We have 1080, x raised to power 3, y raised to power 2. So the next one we're going to do is this. This is 8 times 9, that is 72. All right. Times 10, that is 720x raised to power 2, y raised to power 3. Right. The next one is this. We'll have 2 times 2 times, that's 32. All right, 32 times 15. So our next term, which is this, this is 16 times 5 times 3. That's going to be 240. All right, then we have x, then we have raised to power, y raised to power 4. The last one is going to be 64 y raised to power 5. So using Pascal's triangle, you arrive at this as your final result for this expansion.